Yeah, you can share your screen. What, man? These many number of sets? Why? Are you working on whole building?
No, sir. Sir, earlier when I saw this, it wasn't these much, sir.
2-3 sets lesser than this.
Sir?
Earlier it was like a 2-3 sets lesser than this, right? Not this much. It was lesser than about 2-3.
Not these much, sir.
In this, what is what? How to identify that?
Section 3, what is?
And you have not given any names also to this. The steel aral, it is there, right? Try to select all those things. Select all. Yeah, that steel. No. Only steel lateral. Only steel lateral. Yeah, from set 3. Yeah, come down. No. Yeah, go up. Go. Yes. Till that, click. Replace. And steel aral. Still it is there. Huh?
Yes, sir.
Select them. Oh no. Yeah. Replace. Click on replace at the bottom. It's been copied up with like multiple things and all. Okay. Now select only steel section. One second. You can close this. Close this one. Dismiss. Close. Go to tools. At the top, you have tools, right? Feature, tools, plugins, help. Set. Go to surface. Create. Go to the geometry. Yeah, go to geometry only, and you can name the surface first. That steel, lateral, whatever you want, like squares. Name that also. What is the section name that you are given? Same name you can give.
Steel lateral.
What is that steel lateral that you are saying that?
And this stirrups.
Okay, fine. Yeah, continue. Click on continue. Select all the surfaces here. Select all the elements. Select all the elements. Done. That you want to choose this as an yellow or a pink, magenta or circumferential. You can click on the circumferential. Okay. And now go to display group again. And now select only that steel section that you have. And I don't know, God knows, like when we are solving it, how many duplicates are there in this. Okay, replace them. Okay, give dismiss. Now in the similar way, go to tools, surface, create. Okay, now you can name this whatever you want. Okay, continue. Select all of them. Done. Click on circumferential again. Okay. Now you have to give one tie connections between this and that. So for click on tie, create constraints, click on create constraints. Can name that constraint first. That is between your steel lateral and steel section that you are doing, right? So name it
Yes.
accordingly. Yeah.
Continue.
What is that? Give that name, steel tie. Huh? Okay, fine. Whatever you remember that, you should remember that.
Yes.
Continue. Click on surface. Click on surfaces at the right bottom. Now choose that steel lateral. Yeah, choose that one. Continue. Continue. And again click on surface. Now again select the steel section. Continue. And just give OK. Now what you are saying, that is to your steel lateral to your steel vertical that you are connecting. That means it is got welded or it's got tie up with some other things and all. Okay. With some other extra steel material, or now it's combined together, it's act like a unit. Now this particular unit, again you have to tie up with your concrete block, right?
Yes, sir.
Again go to display group now. Now to this display group, go to search and choose the concrete, replace, and close this one, close this one, and go to a sectional cut of this sectional view, section view, down, 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 right one, right side, yeah. Click that. Where is this? Yeah, you have not accommodated anything there. Any no free space, nothing to accommodate your steel rods over there.
I just merged from the assembly. I just used the assembly module to merge.
No, you just use the assembly module, but what I have showed to use that assembly module also, I have shown you like how to remove the material also, right? Do you remember that
Yes.
class or not?
Yes, sir.
I have shown you, right, how to remove all these things, everything. Then what you have done here? How come, see, if you do it in assembly, merge, whatever it may be, this is the software. Software, it's always depends upon your inputs only. It won't understand the real world. Whatever you say, that is the world for it. I don't know, when these two get penetrated with each other, you will see a lot of convergency issues when you go. But that is again your good luck whether you can go with that or not. I don't know like how to do that also. Internally there is no surface at all. Then how I can able to tie this? I've shown you the videos, right? You people are expecting to me to do the project and give it to you. It is not the case, right?
No, sir. No, sir. We're not.
Then why you are not practicing at all? Ashish, surely I can say that you didn't practice anything. You have not seen to any of the videos. You have all the links, right?
Yes, sir.
And what makes, yeah, on what basis? Like, okay, anyways, do you have any idea like why it is like this or something? I mean, like any reason behind that modeling like that without providing any space or something?
I thought that just we'll merge it and it will take.
How come it will take then? Why I have shown you all those particular classes? Do you remember, right? I have shown you the sectional cut view of it, and then I'm showing all these things.
Partition.
Yeah. In this case, like how at least like internally, I should have some surface, right? To which surface it is in contact. That also you leave it. As an engineer, when you are going something, even like a daily wage worker also knows that if I want to insert the steel beams, I should have some free space in that. Okay, that's why he built this particular block first, and then he start putting the concrete on that. That means once the steel is removed, the concrete block will have that hollow shape inside it.
Yes, sir.
That you should understand, right, as an engineer. So I don't know like now how to proceed, like where to give that particular contact. If I can give that contact to the complete entire block, then it's no use of doing all this analysis at all. Okay, I appreciate for going with 1D elements. Okay, that's fine. But actually, where you have to accommodate that 1D elements, that's very important, right?
Yes, sir.
Without accommodating that 1D, then what we can do? I'm sharing my screen. You can see my screen?
Yeah.
Do you remember this part?
Yes, sir. Yes, sir.
Then for what purpose that I have done all this running things about? This is my ruling, right? So this is what the style, like steel lateral or what you are saying it. This particular entire model that I have shown you, like how to do that. So with the rough dimensions that we went. And to accommodate that in this particular part, that what we have done, we have just created an assembly. And in an assembly that I have shown you that, right? So where we have accommodated, here I have to accommodate, or here I have to accommodate. So I have shown you that. Do you remember that or not?
Yes, sir. Yes, sir.
So these particular holes and all I have created you. Any directions that when you just go like everything I have just shown you, right? So maybe in this assembly, I have not saved all those files because these are all like as the dimensions we didn't have. That's why I think it's lying up over here. But I have shown you like, see, I can just go on like this. I can show you another cut for this. See this one, to accommodate that, it's clearly giving you the gap. to accommodate in another
Yes.
directions. And all the directions I have shown you, right? Then see this when you just go. See this? This is where the space it occupies, right? In the beam, in the middle.
Yes, sir.
Like this, that yeah, that like that I'm expecting it. It's already done. It's already explained for you that you have to see this video, practice it twice, and then try to apply on your section. If you just like stop sharing it, you can share your screen. I just want to show you that whether you remember that or not. That you got it right. You are there in that class. I do remember that.
Yes, sir. Yes, sir.
So then if you just go like this, so to what I have to do and what I need to say that. Okay. So the interaction module that you have to be get a clarity on it. And then go to the loading module. Okay, you have remove that section you cut. Okay. One end you are fixing, one end you are applying. What is that? Okay, in Castor you are doing it. So it's similar to a cantilever beam that you are trying to solve now. Okay. You are applying here as a displacement.
Displacement.
I'm right.
Location. Yes, sir.
Then if you are applying this as a displacement, that 1, 2, 3, 4, 5, 6, 7, 8, 9 to 20 that you are mentioning an amplitude, those values are mm. You should say that right for me. You are multiplying 1 with that particular value in each and every case. So finally that you are applying some mm over there. When you are trying to apply this millimeters, I told you like this entire surface has to connect it to a single reference point, and you have to give this multi-point constraint to that point, and then you have to apply that displacement to that particular point. So the advantage of it, when you go to the results, you can able to measure the force easily. Do you remember that or no?
Yes, sir. Yes, sir.
You got me?
Yes, sir. Yes, sir.
So the loading application also you have to do that. You know how to do that, or you want me to explain that again?
Sir, which one?
How to apply this node? You have to connect all the surface to a single node, and to that single node you have to apply it, so that in the results you can able to plot this load versus deflection curve easily.
Can you tell me once again that, sir?
Go to interaction module, cancel this. So here RP is there, right? RP.
Yes, sir.
Click on that. Create, that's called as a reference point. So reference point actually you have to create in between. Center to that you have to create it. So not that like the surface that where you want to apply the load. So there, don't click. If you click it again, it's a problem. Okay. So there you need to get a pointer, but there is no point there actually to pick this RP, right? So now
Yes, sir.
just give me control. Now this coordinate button, it is there, right? So you can just go to a long cut on this. Now you can click here. So now between this point and this point, you're creating a new point. And to that new point, you can select this one and you can click on here. So now it's a reference point, it got created. So now to this reference point, what you can do, you can just go to your constraints again. Either you can apply type, or it's always better you can just go as an apply coupling. So continue this coupling. Now to this master point that you need to apply this as like this. That's where like, because you are applying the displacement, right? So this,
Yes, sir.
and you can select that particular point, done. And you can create a surface, loading surface. You can name this as the loading surface. You can choose this and get done. And then you okay. So once if you click on this, now this particular surface is tied to that particular reference point. And from here now, whenever you want, you can apply this loading onto this reference point. So you can go to load module. So here you are applying this displacement, right? So particular displacement you can edit, and this is the region that you want to pick is like what do you want to pick? So the master point that what we have defined is a disk point, right? So you can choose the disk and apply. Okay. So now whatever you are applying it, everything will apply to this reference point. This reference point will transfer everything to this so that you can able to capture your load results only at this particular reference point in the future. Okay.
Okay, sir.
Ashish, just give me a second.
Yes, sir. Yes, sir.
Okay, where is Umnesh? Umnesh is not there in this, or he is waiting in the room or something.
Don't know, sir.
Okay, fine. Okay, so this is how you have to apply this. And while plotting the results, no, there's a RP1 point that I'm calling it as a disk, right? So you can plot the results at the disk point, then automatically you can get the force because you are applying the displacement here. Yeah, so now you got it, right?
Yes, sir.
To apply that. Okay. I think only missing here is only the tie constraints. You have to maintain a proper tie constraints, then only you'll get the proper results.
Yes, sir.
Okay, I think in your part, again, this FRP that you are not doing, right? Or the composite wrapper that you are not doing right now.
Yes, sir. So both wrapping and also the surface mount rods, please.
Okay. Okay, you have all the dimensions, start modeling it.
Yes, sir.
You got struck anywhere on this?
Yes, I want to know about this. Actually, I've been guided to model for this biaxial
Okay, table
column.
4, specifications of the material, cross sections, dimensions, internal actions of the considered column. These are all the loads that they were giving it up, right?
Yes, sir. How to give this axial load and the moments.
Okay. You can apply like at the point, you can apply this axial load as a separate and moments as a separate. I'll show you that. Open your abacus, I'll show you that. I'll make this show the full screen.
Sir, can we model this currently, this now, so that I can get a quick.
So what is this FC? FC stands for?
FC is a compressive strength of concrete.
That and all is the material properties, right?
Yes, sir. Yes, sir.
Fy is the yield strength of your concrete.
Fy is the yield strength of steel we are using, 395 MPa.
Okay. And R, what is that R?
This is confusing for me also, so I didn't get. So actually, it was not required also.
Okay. I will show you that like what is how to apply this axial load, how to apply the moments. I'll show you that. Open your abacus, I'll show you that.
Insert these some levers, diameter of 10 mm.
No. First finish one point and then move further. Open abacus. Okay. So here you are applying the displacement, right? So first, can you give me the control?
You have to control this.
I'm giving up the control. Can you? I'll request again. Okay. So you have to create this load first. And in the load that you have to select this concentrated force to apply your axial forces. So here, if you want, you can just name this as your axial force and click on this continue. So on the disk point itself that you want to apply it, click on this, and whatever this is C force in F1 means in X, 2 means in Y, and 3 means in Z. So in whichever the directions that you want, you can apply the force over here. 1, 2, 3, 4. Okay. So, and then you can apply this one. X direction that I'm applying it. Okay. But you can change the directions. And again, if you want to apply this moment, so you can select this and you can go to moment here and continue on this. And now select the displacement over there, continue. And then you can apply like in X moment you have, or Y moment you have, or in Z moment you have. Suppose in Y and Z momentum I have like, so 1, 2, 3, 4, 1, 2, 3, 4, I can apply that. Like this, you can able to apply this one.
Yes.
Okay.
Yes, sir.
And the NSM reverse used in this experiment had a diameter of a 10 mm, tensile strength of 760, and a modulus elasticity. Okay, that doesn't matter for us. Epoxy adhesive used in the experiment had a tensile strength of 27.6 MPa and the modulus of elasticity of 3 GPa. Epoxy, you are not using it, so it's not required much for you. The interactions between the adhesives and the concrete between the concrete jocket were modeled using a tie constraint. Here you mentioned, but you are not applied the tie property. And the boundary of the concrete with the steel reinforcements and FRP rebars was modeled using an embedded region constraint. Okay, it's an embedded region constraint, but you have not partitioned that bar still, right?
Yes, sir.
You have to partition that bar also. Then only you can able to do that.
Yes, sir.
Okay, so you can start doing that. What else you have the doubts?
Yes, sir, that only. These things
So
only.
the tie constraints. Here, the most important thing that you forgot is like tie constraints. If your tie constraints given properly, then you can able to solve your problem within 1 or 2 hours of a time. But if your tie constraints are not correct, then your problem will solve for 2 days or 3 days and end up with a wrong result. Okay.
Yes, sir.
You got me?
Yes, sir. Yes, sir.
So will you be able to model it today? So before, like when we are meeting at 2:30, can you able to show me that?
Sir, actually, after this, we'll be having lunch.
Yeah.
I'll as much as I can. I'll be sure.
After your lunch only, you can start doing that. At what time you have to go for your lunch?
Within 10-20 minutes.
Okay, now I can leave you, so you can just go for lunch, come back, finish it, and then give me a call.
Sir,
At 2:30, I will
I
set up.
will.
2:30 is fine, right? Again at 2:30
Yes,
to 4 o'clock.
sir, actually, I was asking that should I model it again?
See,
Yes.
come back to me and approach like that, how you are going to model it. Don't model it now, right now. Come back to me and
Okay,
approach that, how you are going to model that. Explain me that
okay, sir.
approach. If it is good, then I'll tell you like how to go proceed. I want to think yourself also.
Okay, sir.
Okay, think that and then come back to me and check with Ashish and Dennis also. If they are not
Nice.
attending like this, Umnish. Okay, Umnish and Dennis, you can check with them. If they could not able to make the classes, then I could not able to complete their works also.
Yes, sir. Yes, sir.
Okay. So now break your lunch, take 10 minutes rest and go for a lunch, come back, think on your process. And when we are meeting at 2:30, again, we will see that. Okay.
Sure, sir. Sure.
Okay. Yeah.
Thank you, sir.
Thank you.